Now we're going to explore further finding the initial value. So the initial value is not necessarily always n equals to 1. Sometimes we need to determine it by the question. Now I alluded to this before in the previous question where I said that I always wanted you to remember step 1 as finding the initial value, proving that's true, not that n equals to 1 is true. And that's because a lot of students get familiar with n equals to 1 and think that it's always going to be n equals to 1, which is not the case. So let's have a look at a question where n does not equal to 1 for the first term. So in question 2, we want to prove that 1 plus 3 plus 5, so on, to 2n plus 1 equals to n plus 1 squared by mathematical induction. Now, remember the 2n plus 1 was just the general formula for each of the terms in this equation. So if you this represents the first, the second, and every single term in that, yeah? Okay, now what I want you to work out is what is the initial value of n to get the first term. And remember how we do that is firstly by considering the general equation and then the first term. So we want to work out what does n have to equal for it to equal to 1. And so we can just quickly work that out. 2n plus 1 equals to 1, 2n equals to 0, so therefore n must equal to 0 for the first term to equal to 1, doesn't it? So that's why in step 1 we want to say show it is true for n equals to 0. Yeah? So what I want you to think about is your first part of step 1 is always finding out the initial value of n just by doing this. And then you can say show it is true for n equals to whatever value it is. Now I think it's always good to check, so substitute 0 in there, you know that equals to 1. Whereas, can you see if we actually just put in n equals to 1, we'd have 2 plus 1, which is 3. So then we'd actually be starting off with the second term, which throws this whole thing off because we're not having that initial starting point, that initial push for everything. Okay, so how do we show it's true for n equals to 0? Well, we would consider the left-hand side first. So we have, using this general formula, 2 times 0 plus 1, which equals to 1. And then we consider the right-hand side. So using this equation, we have 0 plus 1 squared, and that equals to 1 as well. So we can say that the left-hand side does in fact equal to the right-hand side. So therefore, it is true for n equals to 0. Okay, so now we've done step 1. Remember what step 2 was? Yep, so that was the assumption that we make. So step 2 was making the assumption that this is true for n equals to k. That is, when we substitute in k, we're making the assumption that the left-hand side does actually in fact equal to the right-hand side. So can you see how all I've done here is just put k into wherever there's n. Now, remember how step 2 is important because we're always going to be using that assumption for step 3. And if you don't use that assumption, you know something's wrong.